Determine the equation of a line that intersects the positive x-axis at 4 and the negative y-axis at 3. Okay, let us begin. So first what we'll do, we're going to consider the xy coordinate plane. Now, we need to find a line which is going to intersect the positive x-axis at 4 and the negative y-axis at 3. That means that the line is going to pass through 2 points on the axis. Wow, it's going to pass through the x-axis such that it meets the x-axis at 4, meaning that this particular point of intersection is going to be 4 units lying to the left, to the right of the origin O. And then we have negative 3 units below the origin or below the x-axis, meaning the line is going to pass through the point on the y-axis, on the negative y direction of the y-axis, such that it cuts off negative 3 units along the y-axis. Okay, now what we'll do, we're going to consider a straight line that is going to pass through these 2 points, and our goal will be to determine the equation of this line. Now that's a very simple task here. So here our x-intercept value, this is denoted by A, so that is 4 units. Our b-intercept value, that is given as negative 3 units. We know that the intercept form of a line is given by the equation x over A plus y over b equals to 1. So this is referred to as the intercept form of a line, the intercept form of a line. Now where A is the x-intercept, A is referred to as the x-intercept, and B is the y-intercept value. And we are given these two values, A that's equals to 4 units and B that's equals to negative 3 units. We're going to substitute this value into our equation, the intercept form, to get x over 4 added to y over negative 3 equals to 1. So this is the equation of the line, and if we keep the equation in this particular format, then this is going to be the equation of the line given in the intercept form. Or what we can do, we can simplify this. We have to take the lowest common multiple of 4 and 3. We know that the lowest common multiple, that's going to be given by 12. All we have to do is multiply the equation throughout with 12. That's going to give us 3x minus 4y equals to 12. And this is going to be the required equation of a line such that it intersects the x-axis at 4 and the negative y-axis at 3. Okay, the first one is done. Let's go to the second problem. We need to find out the equation of a line which cuts off intercepts 3 and 2 on the axis. Now, it's not a specifically mentioned here which axis has got an intercept of 3 and on which axis we have an intercept of 2. So here, by convention, we will choose the first intercept to be the intercept on the x-axis, and the second value, which is 2 here, we will consider it to be the intercept made by the line along the y-axis. And since both are positive values, so we'll consider only the positive x-axis. So that's the axis to the right of the origin, and y-axis is going to be the axis that's above the origin. So let us consider 2 points. One of the point is going to be 3, 0. This is the point that lies on the positive direction of x-axis, and we'll consider another point 0, 2, which is going to lie on the positive direction of y-axis. We're going to now consider a straight line that passes through these 2 points, and our goal will be to determine the equation of this line. Now that's a very simple task. So here A, that's going to be equals to 3 because the x-intercept value that's equals to 3 and the y-intercept value given by B that's equals to 2 units. So here we have A equals to 3 and B equals to 2. Okay, so that means our equation is going to be, equation of the line is going to be x over 3 added to y over 2 equals to 1. So this is the equation of the line, and it's given in the intercept form. And if we want to further simplify it, what we'll do, we'll consider the lowest common multiple of 3 and 2. That's going to be equals to 6. Multiply throughout with 6. That's going to give us 2x plus 3y equals to 6. And this is going to be the equation of the line which cuts off intercepts 3 and 2 on the axis. Okay, let's go to the third problem. At this time, we need to determine the equation of a line which cuts off intercepts -5 and 6 on the axis. So this means that a value that's equals to -5 and b value that's equals to 6. Finding out the equation, that's extremely easy. We'll come to that in a moment. Let's try to understand it graphically. So since a value is -5, so what we'll do, we're going to consider a point on the negative direction of x-axis such that that point lies 5 units to the left of the origin. So that means this particular point corresponds to the coordinate value -5, 0. Let's call it point A. And then we're going to consider another point along the positive direction of y-axis. So let's say this is the point B, and this is going to have the coordinates 0, 6. This simply means that the point B lies along the positive direction of y-axis at the distance of 6 units above the origin O. Okay, so what we'll do, we're going to join these two lines, and that's going to give us a straight line, and our goal will be to determine the equation of this line. That's again a very simple task. We have x over -5 added to y over 6 equals to 1. So we consider the lowest common multiple of 5 and 6, so that's going to be equals to 30. So what we'll do, we're going to multiply both sides with 30, so that's going to give us -6x added to 5 times y equals to 30. Let's do one thing. Let's make the coefficient of x positive. So we're going to multiply throughout with -1 to get 6x minus 5y equals to -30. So this is the required equation of the line which cuts off intercepts -5 and 6 on the axis.